All right. Question 18 asks what the least possible value of any term in the set is. So first of all, let's just draw 6 lines. We have 6 terms, and you know that the mean is 8. And if the mean is 8, then that just means that your sum is 8 times 6, or 48. So 48 is the sum of all the digits. Okay. And then the problem says that you have a median of 8 as well. So if your median is 8, then that means these middle two numbers, we'll call them x and y, then your middle two numbers, their sum, they'll add up to 16. So that means that for the rest of the 4 terms, the sum of the 4 terms, that means that those 4, the first 2 and last 2, their sum will be 48 minus 16, which is 32. Okay. So if we want to find the least possible value of anything, then we want to make the last 2 digits, the last 2 terms, as big as possible. So the problem says that no term can be greater than 13. So we're going to have 13 be our last term. And then we're going to have 12 be the 5th term. So 12 plus 13 adds up to 25. Yeah, 25. And that means that the first 2 terms, their sum will be not 48. Their sum will be 32 minus 25, or 7. So the sum of these are 7. Okay? So if the sum is 7, then we already know that the smallest possible number can be 1. And that just means the second one is 6. So basically, the answer is 1. Next is question 20. So we know that, okay, we have 2 triangles. Yeah. First of all, we know that triangle AXY is congruent to triangle ABC. So we can use proportions, ratios to find what this ratio is. Okay? So the area of triangle AXY is 8, and the area of this trapezoid is 10, so that means the area of triangle ABC is 10 plus 8, or 18. So we're gonna do this, okay? We're gonna put the area of triangle AXY on top and the area of triangle ABC on the bottom. This is AXY, ABC. Okay. Sorry. So, So the ratios of the 2 areas of the triangles is 8 to 18. And to find the side ratios. Hold on, let me clear my throat. This is awkward. Okay, we're back. So the ratios of the sides is just like, for example, if you want to get to this ratio, then you're going to divide the ratio of the areas. Well, not divide, take the square root. Because, yeah. So then, when you take the square root, you get 4. Oh, wait. That's a bit hard, actually. First, let me just simplify this. Let me simplify this. So you have 4 over 9. Yeah, that makes things easier. So when you take the square root of 4 over 9, you get 2 over 3. So that just means that the sides of the triangle AXY is two-thirds of the side lengths of the triangles of the triangle ABC. So that also means that this ratio, this fraction, is equal to xy over bc. So 2 over 3 is your answer. #21. #21, you want to find the greatest possible absolute difference between the mean and the median. Okay, so you have five terms, and if we want the greatest possible difference between the mean and median, so it'll be easier to make the median as small as possible. So the smallest possible value that we can make the median is 1, since 1 is the smallest positive integer. If the middle digit is 1, then that means all the terms before it is also 1. Now we just have to find these last two terms. And we want the greatest possible mean. So to do that, we set these two to be as big as possible. And in this case, the biggest digit is 9. Okay. So now we can find the mean. The mean is just 1 plus 1 plus 1 plus 9 plus 9 divided by 5. So that's 21 divided by 5. And we also know that our median is 1. Sorry. Now we just have to take the difference between these two. So 21 over 5 minus 1, that gives you 16 over 5. And that's our answer. 23, you have the sum of an arithmetic progression. Okay, let's just let x be the first term, and we're going to let y be the difference between the terms. And knowing this, we know that our first term is x, our second term is x plus y, our third term is x plus 2y, fourth x plus 3y, fifth x plus 4y, and our last term is x plus 5y. Now we just have to add all of these terms up, and basically you'll get 6x plus 15y And this is equal to 78. Knowing that, we're going to simplify this expression. We're going to divide both sides by 3. And you'll get 2x plus 5y is equal to 26. So we want, we want to make y as big as possible. And to do that, we want the smallest possible x. And to do that, first of all, we're going to work from x equals 1 and up. So we want to make 26 divisible by 5. So the smallest possible of x that accomplishes this is 3, since 3 times 2 is 6, and 26 minus 6 is 20, just 20. So if x is 3, then that means y is 4. And that's our answer. Sorry. 25. 25 is next. Oh, 25 is a bit hard. It's just really tedious. Okay. So, yeah. First of all, we know that we want to know what the sum of all of these expressions are. And we know that all of these expressions are equal to some value between 1 and 6. And each expression has a different value. So that means our sum is just 1 plus 2 plus 3 plus all the way up to 6. And that's just equal to 21. So our sum is 21. Now we're going to add up all of these expressions. So, yeah, I'm not going to do that now. Hold on, let me clear my throat again. Sorry, this is awkward. Right. So if you add up all of these expressions, you'll get 6a plus 6b plus 9 is equal to 21. And we can simplify that even more. So we're going to move the 9 to here, and you'll get 12. And that means 6a plus 6b is equal to 12. If you divide both sides by 6, then a plus b is equal to 2. Now, looking at these expressions, looking at the expressions with b, we can see that b has to be negative, since if b is not negative, then none of these are possible. None of these will be between 1 and 6. So now we just have to guess and check, honestly. Actually, we're going to take this equation. It looks a bit complicated. And we're going to find what b can be. So we know that 3b plus x has to be between 1 and 6. And if you solve for b, you'll find that b has to be between -4 and -3. So b is equal to either -3 or -4. Okay. And now we just have to guess and check. We have to find which value b is. and we're gonna try -3 first. We're gonna use B to solve for A. And to do that, we have to plug in B into all three of these equations. So B plus 8 is equal to 6, 3B plus 10 is equal to 4, and 2B plus 5 is equal to 1. Okay, now we're going to add these all up. That's 11. And that means that these three expressions, the ones with A, their sum is equal to 21 minus 11, or 10. And now that we know that, we can add all of these expressions together. So a plus 1 plus 2a minus 5 plus 3a minus 10. We can add those all up to get 6a minus 14. And that's equal to 10. Now we just have to solve for a. A is equal to 4. And we have to see if this value satisfies all of these equations. And we're gonna do that right now. So a plus 1 will be equal to 5. 2a minus 5 is 4. Wait, 3. Yeah, 3. And then 3a minus 10 is 2. Okay. So now that you see this, we see that there are no repeats. And that means that B is in fact -3 and A is 4. So we just multiply those together. -3 times 4, that is equal to, wait, hold on. Oh, bruh, sorry. I meant B is equal to -2. Yeah, I put in I meant to use -2. I forgot to write that down. Yeah, B is -2. So that works for all of these too. So B is -2. -2 times 4 is -8. And that's your answer. Okay, 26. Let's use a different color. We're going to find the 2015 term, and let's just look for a pattern first. So you know that A1 is 3, A2 is 5, and A3 will be equal to 5 minus 3, that's 2. The next term will be 2 minus 5, -3. And then -3 minus 2, that is -5. And then the next one will be -2, 3, 5. Yeah. So looking at this, we see that the pattern will repeat every 6 terms. So we just divide 2015 by 6 to find the remainder. And the remainder, which is 5, the remainder will tell us everything. So we have a remainder of 5. So we want to choose the 5th term of the pattern. And in this case, that is -5. So the 2015th term will be -5. Okay, this dude is flipping a coin. And we want to find the probability that he will get the same number of heads and tails. Okay, let's switch colors again. So if he flips a coin 8 times, then that means he'll flip 4. Wait, is she a he? Oh, it's a he. He'll flip 4 heads and 4 tails. Okay. So we want to find how many. All we have to do is find how many ways Daisy, whatever, how many ways he can flip. Well, how many ways he can flip 4 heads, and basically how many arrangements he can do to flip 4 heads. So out of all 8 times, only 4 of them have to be heads, and the rest can just be tails. So we just have to choose which 4 times will be heads, and that's just combinations. We use combinations. 8 choose 4 choose 8. Oh, no, 8 choose 4. Yeah. And this is equal to 8 times 7 times 6 times 5 divided by 4 times 3 times 2. And we just have to simplify this to get 70. So 70 is how many possibilities there is for 4 heads and 4 tails. And now we want to find the probability of actually getting this. So 70 will be our numerator, and our denominator will be the total number of ways Desi can flip stuff, and that's just 2 to the power of 8, since every time he flips a coin, he only has 2 outcomes. This is 70 over 256, and that can be simplified to 35 over 128, and that's our answer. $28 is next. Okay, let's switch colors. Okay, so we want to find how many ordered pairs of x and y that satisfies this equation. Okay, we're just going to use casework to solve this. Casework. Okay, case 1 is when both x and y are positive. Oops, yeah. So this means that x plus y will be equal to y plus x. And basically, x can be any number between 0 and 10, and y can also be any number between 0 and 10. So that means that there are 11 possible values for x and 11 possible values for y. So that's equal to 121. I'm gonna move this real quick. Might run out of space. Case 2 is when x is negative and y is positive. So in this case, nothing will work because you can just plug in random values. Like, say x is 2, and we're going to do 2 plus negative. Oops, I switched it around. Let's switch this around. Okay. Say x is negative 2, and then y is like 3. that means that this side of the equation will be 3 plus this. Yeah, this will never work out. So this will never work. There are 0 possibilities. And then case 3 is basically the same as case 2. So you have x positive and y negative. And just like case 2, nothing will work out. So you have 0. Finally, you have case 4, and that's when both are negative. So when both are negative, the only way that this will work out is when x is equal to negative y, or y is equal to negative x, same thing. So x and y, they have to have the same value, except that one of them is the negative value of that number. So for example, if x is -1 and y, and that means y also has to be -1. Yeah. Let me erase this. We're out of space. Basically, only cases like -1, -1, -2, -2, only these types of cases will work where both numbers are equal. Let me write that better. And so there are only 10 of these types of cases, since you only have the numbers -1 all the way to -10, -10. So that means that there are 10 possibilities for case 4. So now we just add everything up. Well, there's not much to add, but 121 plus 10 gives us our answer of 131. Okay, 29. Yeah, there's probably a smarter way to do this, but it's very complicated. It's too hard to explain. So honestly, you might as well just do long division for this. Just divide everything. Yeah. And when you do this, you'll get, you'll find that 1 over 98 is equal to 0.0102040816, where 6 is our 10th term. There's another method that involves summation, but I don't think most of you know what that is. You'll learn it later, hopefully. Question 30. After we do question 30, you can ask whatever questions you have, if we have time. We'll probably have time. We might need, yeah. Hold on. Let me make more space. There. Okay, we want to find the greatest possible value of m. So first of all, this is big and fat. First of all, the external angle of a regular n-sided polygon is 360 divided by n. So if it's m-sided, if it has m sides, then the external angle will be 360 divided by m. Okay? So now we can create an equation. We can create this equation. 360 divided by n minus 45 is equal to 360 divided by m. Since the 45 comes from the problem, we want the exterior angle of n to be 45 degrees larger than m. So, oh no. Yeah. So now we want to solve for m. Well, we only have one equation, so we can't actually find an actual value for m, but we're going to express n. We're going to express m in terms of n. So, yeah. To do this, let's just set this equation up so that we can cross multiply everything. Okay. Now we can cross multiply. 360n is equal to 360m minus 45nm. And now let's just divide both sides by 8. No, not 8, that's too small. By 45, and we'll get 8n is equal to 8m minus m and n. So we can express this side of the equation by m times 8 minus n. So that means that m is 8n over 8 minus n. And now we just have to find the biggest n, m, I mean. And there's really no smart way to do this. You just have to list out all the possible values of m and find the biggest one. And to do that, we're going to make a table. N will be here and m will be here. So if n is 1, that means that m is 8 times 1 divided by 8 minus 1. So that's 8 over 7. If n is 2, then we have 16 over 6 or 8 over 3. If n is 3, we get 24 over 5. If n is 4, we'll get 32 over 4 is equal to 8. 5, 40 over 3. Oh, I'm running out of space. Oops. Oh no, what did I do? Anyways, if n is 6, you get 48 divided by 2, that's 24. I need to make this longer. If n is 7, then you get 56 over 1, that's just 56. And then 8, you get 64 divided by 0. Well, this is not possible, so this is just undefined. And then if n is 9, then at this point we just go into the negatives. It's like 72. From n, from every value past 7, then is some random negative number, and that's not good. So we just have to choose the biggest value of m from all of these first 7 terms. And you can clearly see that when n is 7, m will be the biggest possible m, which is 56. And that means that our answer is 56.